Hello friend. In second lecture of my about the pointer, we will learn on the some operation on the pointer like increment, decrement, and some more operation. This slide we have already see about the pointer and the data types. Okay. Today we will discuss about the operation on pointer. See, as represented in slide, increment operation on the pointer is possible. Decrement operation is also possible. Third, pointer plus by some integer value, it is also possible. Fourth, differentiate between pointer means pointer 1 minus pointer 1, you are subtracting one pointer from another pointer is also possible. Some of the operations are not possible, like pointer 1 plus pointer 2, that means pointer 1 variable plus pointer 2 variable is not possible. Multiplication also not possible, division is also not possible, and modulo operation is not possible. These are operation not allowed, and above 4 are allowed. Okay. Now let's see about the increment operator. We will learn by some example, so it will be clear for you. See, in lecture, last lecture, I mean in part 1 we have covered up to p7.c. I will write p1 p8.c file here. Just try to understand the program and we'll explain. As include stdio.h integer main. See, I am declaring one integer pointer with value 258. Now integer pointer, I am declaring integer pointer, declaring one character pointer. Okay. Now I am assigning an integer pointer the address of I, and again I am assigning in character pointers again address of I. This is allowed. In my part 1 lecture we already see this operation or these things. If you are not gone through my part 1 lecture about the pointer, please go through the part 1 and check once. You will understand better. Now I'll print address of I percentage d slash n, then address of I, then now print up, sorry, now IP, I am printing value of IP, which is nothing but address of I. Now I am trying to print IP plus 1 percentage U, here also U, not T. Okay, slash n, then IP plus 1. Okay. Now same thing I will do for character also. Character pointer, I am printing value of CP, which is nothing but address of I. Increment is CP plus 1, character pointer CP. Okay, this is clear now. Till now it is clear, right? So declaring integer I with value of 258, declaring integer pointer, character pointer, assigning address of I into integer pointer as well as character pointer. Now I am printing value of address of I, then address value of integer pointer, character pointers, then I incrementing plus by 1 and integer pointer and character pointer, and I'm trying to print. Let's first compile this program. GCC -o p8. We can leave this only for the time being. P8. See, address of I is this one. Just look at last 3 digit. See, the address of I is 964. Just look at 964. Which integer pointer is holding same address? So it is same 964. Character pointer also holding same address, which is also same again. Now see, look at here, IP plus 1. What is printing? See, 964, then 961. It's 968. What happened? 968. Okay, do you see some difference? 964 to 968. See, in case of character pointer 964, and then see character pointer plus 1 965. So this is difference between character pointer and integer pointer, that already we discussed yesterday. Just showing example and covering increment operation also. So when you increment integer pointer, it will increase by, it is increased by pointer size. It is increased by 4 byte. It is increased by integer size. I can say. In case of character pointer, also it is increased by its data type, its size plus 1. Character means 1 byte. Integer means 4 byte. So that's why integer pointer is incrementing plus by plus 4. If you again increment, let's say IP plus 2, then it will be 972. In case of character pointer, if I do CP plus 2, it will be 66. Let's try that also. IP plus 2, CH plus 2. Here I am printing CH plus 2. This is for just for understanding. We miss one slash here. This also IP plus 2 percentage U. Here no I percentage U comma here. Okay. Something I miss. Okay, this way. Okay, now it's clear. Now let's compile. Sorry, CP, not CH. CP. Let's compile. Let's run it. See, as I told you, address change when you run again. But see, difference is 420, 420, 424, 428. Increase by 4. In case of character, 420, 421, 422. Increase by 1. So this is what the difference I want to show you here. So if you increase integer pointer by 1, it will increase by 4. If you increase character pointer by 1, it will increase by 1. Same again, same case. If you increase float pointer by 1, it will increase by 4. Okay, this is clear, right? Okay. Okay, now let's take one more example. Cp p8.c p9.c p9.c. Okay, see here up to this is here. Now this is also okay. Now I am printing value of CP first here. Print up. I am dereferencing CP. I am trying to dereferencing CP, which is holding address of I. Just I am dereferencing it. Sorry, start CP. Now I am incrementing CP plus by 1. Again I am printing CP. Okay. See now. Let's compile this p9.c. O p9.c. Ignore it. Ignore the zoning. See here. First it print 2, then 1. Why? Let's see binary representation of 258. So just I'm writing here fourth byte third byte I think 8. Okay, then 0 0 0 0 0 0 0 0 1, then 0 0 0 0 0 0 0 1 0. See, first this CP pointer was pointing to 68 address, 468 means here, so it has printed true. It has printed true. And as you know, character pointer point to 1 byte only. We have already seen my part 1 lecture of pointer. Now we are incrementing plus 1 in code. So now next it will point to this one. So it is printing 1. This is what, this is way we can confirm that character pointer is increased by 1, and it will point to 1 byte only. Okay, so this way we can say that integer pointer focus on 4 byte, and if we increment it will point to next 4 byte. In case of character it is point to 1 byte, and if we increment it will focus on next 1 byte. In case of float pointer is pointing to 4 byte, and if we increment it will point to next 4 byte, but it will treat those data as a float. IEEE 754 format that we'll discuss. In case of double pointer it is point to 8 byte. If we increment by 1 it will point to next 8 byte. Okay, okay, I hope this is clear till now. Okay, okay. Now let's see some important question, important operation on pointer. So we'll cover this operation. So what does it mean by, so p plus plus, this p plus plus means what? Here in case of first, here we are incrementing pointer variable, whatever is pointer type. We have discussed till now integer pointer, character pointer, float, double also we discussed. But in this, in respective of pointer type, we are just discussing on pointer. This first operation p plus plus, p plus plus means we are incrementing pointer. Second, second, first we are dereferencing pointer, then we are incrementing pointer. Second, we are dereferencing pointer and then incrementing pointer. Third, we are incrementing where p is pointing. We are incrementing value where p is pointing. Third, here we are first we are incrementing pointer, then dereferencing it. Here this fifth and third is same. Six, we are increment we are incrementing the value where p is pointing. The difference in third and 6 is, here we are post incrementing value where p is pointing, and here in third we are pre incrementing. Okay, I hope this is clear. Let me go through once again. In case of p, here in p, here first one, we are in post incrementing pointer. Second, we are first dereferencing the pointer, then we are incrementing pointer, post increment. In case of third, we are incrementing value where p is pointing, but it is pre increment. Fourth, we are pre incrementing pointer, then dereferencing where p is pointing. Fifth, we are pre incrementing the value of variable where p is pointing. Six, we are post incrementing value where p is pointing. Okay, I hope this is clear. If you have still any doubt, please write a comment in comment box. I will explain you in detail. Okay, now we'll discuss void pointer. Void pointer is generic pointer. It doesn't have type. It's generic pointer, and we can use it in many application, many, and it can, we can assign value of any any variable type. But while dereferencing time, we need to take care. We need to use typecast. Otherwise, compiler will generate error. Let's see one example on void pointer. 10.c is include stdio.h integer I is equal to 10, character ch is equal to a. We can do right, right? Float f is equal to 20.5. Just number I'm assigning. Now I declaring void pointer. If you can declare void pointer like this. This is the declaration of void pointer. Now in void pointer I'm assigning value of I and I'm printing value of I using void pointer. So this way I can print %d slash n and then same as this one. Okay, this is correct. Okay, will it generate any error? I am not typecasting anything. I am not using any special method to dereference void pointer. Let's see what happen. See, this compiler generates some error. Invalid use of void expression. Now let's typecast it. We have to dereference, but we have to tell compiler this p is considered as a integer pointer type. Now check 10, no error. Now run it 10. Let's do same exercise for float also. Now in app, in p we are assigning address of ch, printing printf %d. This is a. We are printing in %d format. It will print ASCII value of a. Then star p will discuss address of f, printf percentage f %d. We are printing. It will print some chunk value. Let's print in a format. Proper. If we print into %d, it will print some chunk value. We don't want that. See here. This way it will not print any value. It will compiler will generate any error. We need to tell compiler this p is void pointer. So we need to tell compiler treat as a character pointer type. Here p hold value, p hold address of float variable. So we need to tell compiler this is float, treat as a float. Then only it print correct way. And even the compile the program. See, correct. Now you can see p10.c. See, this ASCII value of is 97. That's why it's printing 97. You can see like ASCII a small a ASCII value is 97 in decimal. This one, okay. That's why it's printing 97. Okay, and this cast is temporary. Whenever we are using void pointer, that time we need to cast, and it is temporary. Okay. Hope this is clear till void pointer. Okay. Next, we'll see null pointer. What is null pointer? Null pointer is pointers withholding null value. Assume null pointer is a pointer which holding null value. What is null value? It is just has defined null by void star 0. Zero value. Null is nothing but zero value, but is typecasted with void star. Okay. And if you dereference null pointer, OS will generate segmentation fault because it is not correct pointer. Let's see example of that also. p11.c as include stdio.h integer main see. Let's write integer p. I'm assigning null, and if I dereference this p, it will generate compilation. It will program will compile, but it will be segmentation for. If you are dereference the null value. See, let's see program. Let's compile a program p11. Program compiled successfully. Run segmentation for. Okay. So this null pointer is basically, so what is the use of this null value? This null value in our when you work on application, you will use this value when for dummy initialization of some pointer value. When you use in your, you can use in the application when you work, you can initialize with some dummy pointer, and this is common use. Okay. So in this sector, we are covered on pointer operation on pointer like increment, decrement. Mostly some of the uh, most important operation also pointer also we see. If you have a problem, please write in comment. Then we have check a void pointer as well and null pointer also with some example. I hope this example is clear for you. Still, if you have any doubt, you can write in comment. Okay. Next. Okay. So I'm stopping here, guys. Please like, subscribe, and share this video. Thank you.